Use synthetic division to divide polynomials. Synthetic division is an easy way to divide the highest degree polynomial by binomials of the form x minus c. It is much faster than long division. So we do this example. Use the synthetic division to divide this polynomial. So this is dividend, which means this is p of x. This is your p of x. And this is your divisor. Now, when we have the synthetic division, you have to make sure your polynomial has a descending order. And the space is a key component. If there is a missing term, you have to keep the space there so that you will not make a mistake when you solve for the synthetic division. So the first thing is we reorganize the polynomial into the descending order. That means the highest degree power stay in the front. So we will have power 4, power 3. There's no power 2, right? So we have to keep the space there. Now let me show you how to do the work. Synthetic division, we only record the numerical term. So the unknown, the x term, we don't write it down. We just keep the number term. So I have the power 4. This is coefficient number is 3. The power 3 term, coefficient number is negative 8. So I write down 3, negative 8. There's no power 2, right? So I keep the 0 here. Let me put down on the top, x power 4, x power 3, x squared. X term is a 10. X0 term is 3. And I draw the box like this way. You might see another way they they structure the pattern of the synthetic division, but they should have a very similar way to solve it, okay? But this is the way I do the work. The divisor we have for this question is the factor form is x minus 2. So when we perform this factor into the synthetic division on the outside term, we only record a numerical term. So how can I get a numerical term from the divisor here? You just simply just set x minus 2 equals 0. And then from here you solve for x is 2. So I put a 2 on the outside. Now, we always drop down the first term. Drop down the first term. I have the 3, so I drop down 3 here. And this number is below or outside of the box. Now you start to multiply this term with outside 2. So multiply this 2, you get a 6. Now this 6 squeeze back to above the box. No, above the line. Okay. So the first term, just pull down the first term. Just go under the line. And then use this term to multiply with the outside number. The product, you squeeze the product back to above the horizontal line or inside the box. I call this as a box. I hope that makes sense to you. So the 6, now you combine the 6 with negative 8, so you get a negative 2. You add. Long division, we subtract from the top to the bottom. Synthetic division, we add these two terms. Now we multiply negative 2 with the outside 2. So negative 2 multiplied with outside 2, the product is negative 4. Same way, you squeeze the negative 4 into above of the line. So now negative 4 combined with 0, you get a negative 4. Then you multiply negative 4 with the outside 2. You get a negative 8. So negative 8, same way, stay above the line. Now 10 plus negative a, you get a positive 2. Do that one more time. You multiply 2 with this outside 2, so 2, 2, 4. Now sum these two, you get a 7. This 7 is your remainder. Okay. The last term, whatever you have here, the last number, if you have 0 here, that's a perfect. That's what we want. That means this is a factor form of the polynomial. If not, you will have the remainder. So the last term always carry the remainder. It could be 0 or non-zero, but both of them, they are correct. When you have 0, that means this is a factor. When this number is not a 0, that means it's not a factor. How about the other 4? What do they represent for? This term is the number term, constant term. Then you have the x term, x squared term, and the x cubed. So if I perform the quotient and the remainder form back into this polynomial, we will write down, let me scroll down here. They give us that solution here. We use this polynomial to divide by x minus 2, right? And then this 4 number here, 3 represent it carry with x power 3. So you have the 3x power 3 minus 2x squared minus 4x plus 2. And then you plus the remainder over your divisor, which is x minus 2. So this would be the way you perform the work. When you have this polynomial divided by x minus 2, this is your quotient, and this is your remainder. So this is r, this is your cube. So your remainder has 7 over x minus 2, and x minus 2 is the divisor.